In section 2.5, we're covering this topic of variation, and there's two types you can see in my goals. We're going to be constructing a model using what is called direct variation, and then we're going to look at something called inverse variation, and then we're going to be using a combination of the two called combined variation, and there's also this joint variation that we're going to talk about. So let's just jump right into some examples. First of all, direct variation I've given to you in its very basic form, in equation form. It looks like this, where you have y equals some number that we identify as k times x. And x and k have to be positive. That's all this is saying. X has to be greater than or equal to 0. We call this number k. Some books call it the constant of proportionality. Some books call it the constant of variation. But k is really the number that we've got to come up with in order to make our model. And you're going to see that in just a little bit. So just keep in mind that direct variation implies multiplication of k times x. Y equals k times x. Inverse variation implies division, k divided by x. So the way we find k is different for each, obviously. I'll go back. The way we find k for direct variation is we just think about what we would do to solve for k. We would divide both sides by x, and so that's what this is saying. The way you find k is just do y divided by x. And over here, if you wanted to solve for k, you would multiply by x on both sides. And so that gives us this equation. Okay, so that's in general what direct variation and inverse variation look like. Now let's give you some help on some of the homework problems 3 through 10, where the directions are write a general formula to describe each variation. Okay, so right away, number 1 says y varies directly with x. So in general, what this is saying is y is equal to some number called k times x. So our job basically in this problem is to find out exactly what that number is. And that's the purpose of these numbers. They're going to give us a couple of numbers to plug in for x and y in order to solve for k. So let's go ahead and do that. Y is 6. We're going to solve for k. X is 15. And now dividing by 15 on both sides and reducing because 3 goes into both. And so what we have now is our model. It's called a general formula here, but the final answer, now that we have a specific number for k, is y equals 2/5 x. And that's really all there is to it. On 3 through 10, your job really is to take the information that you're given, know what it means to vary directly and inversely, and plug in the given numbers, solve for k, and then come up with an equation. Okay, let's take a look at an inverse variation example. G varies inversely with m squared. So what that says is G is equal to k divided by m squared. Okay, notice I give you the values, a couple of values for G and m in order to find out what k is. So let's put 8 in for G. We're going to put 2 in for m, and then we got to square it, so that's going to make 4. So k is 32. So my final answer, this becomes the equation G is equal to 32 divided by m squared. All right, let's take a look at a couple more. Let's see what it means to vary jointly. Whenever you see x varies jointly, that means x is going to be equal to k times 2 other quantities, 2 other variables. Okay, so we'll just go ahead and write it up here. Varies jointly with the square root of t. So we're going to be multiplying k times the square root of t and the square of b. So varies jointly is all multiplication, and it's going to be multiplying by, it could be many. In your case, it's just going to be 2 other quantities times k. Okay, so now these numbers, these values for the variables, can be plugged in order to find out exactly what k is. So I'm going to put 10 in for x, solving for k. I'm going to put 5 in for t, and I'm going to put 3 in for b and square it, and that makes 9. So 10 is equal to 9 times the square root of 5 times k. All right, so you might want a calculator for this one. So to find k, we're going to have to do 10 divided by 9 times the square root of 5. So I'm going to grab my calculator. And it looks like it's 0.496903995. And in case like this, you don't have to round or show all of those. I'm going to go 4 decimal places, get as exact as you can. So to finish off my answer, now that we know what k is, we'll just plug that in. So x is equal to 0.4969 times the square root of t times b squared. All right, so that's a varies jointly example. And I'm going to help everybody with this problem number 21, because you're going to be doing number 22 in your book as part of your assignment. Number 21 matches up with it pretty closely. So reading the problem here for 21, the monthly payment P on a mortgage varies directly with the amount borrowed B. Okay, so just putting that into equation form, payment, which is lowercase p, varies directly with the amount borrowed, which is uppercase B. So we can kind of get a start as to what this equation is going to look like. And now we're going to have some information provided to us to help us find out what the actual number that we plug in for k is. So the next sentence says, if the monthly payment on a 30-year mortgage is $649 for every 1,000 borrowed, find a linear equation that relates the monthly payment P to the amount borrowed B for a mortgage with the same terms. All right, so monthly payment is $649 for every 1,000 borrowed. So B is the amount borrowed. So this is going to enable us to find out what K is. So you just go to your calculator and do 6.49 divided by 1,000. And that's 0.00649. So our general equation here is going to be P equals 0.00649B. Okay, so that's kind of like answer part 1. So you see where the last sentence says then, all right, so we'll just call this answer part A. Then find the monthly payment P when the amount borrowed is $145,000. So we just take our equation that we came up with and use our number for K and let B become $145,000. And go to your calculator, and that monthly payment is $941.05. So that would be answer part B. All right, so your number 22 is very similar to that. So hopefully this example will help you out. And then this word problem is a lot like your word problem number 31. So when you get to 31, you might want to look back and see what we did here. So let's see what we have. Maximum weight is of a piece of pine. Here's the key word, varies inversely So weight varies inversely with length. So putting that in equation form, it would look like this. Weight varies inversely. Remember, that always implies division, and L is the length. Okay, so now they're going to give us some information to help us find out what K is. Experiments indicate that the maximum weight of a 10-foot long 2x4 piece of pine can support 500 pounds. Okay, so weight of 500 is supported by a length of 10 feet. So according to this, K is 5,000. So our equation for this particular problem that we're going to use to answer the question is going to be W equals 5,000 divided by L. Now, okay, so we just did this. We wrote the general formula relating weight to length. Now we're going to, so that's answer part A. Now we're going to find the answer part B. Find the maximum weight, so we're finding W, if the length is 25 feet. So simple enough. All we have to do is replace L with 25, and that's 200 pounds. All right, so take a look at that example when if you need help in doing number 31. And I got one more for you. So this matches up pretty well with your number 39. So let's see what this looks like. The force of the wind on a flat surface positioned at a right angle to the direction of the wind varies jointly. Remember what that means. So it's all multiplication. So force is going to vary jointly. So it's going to be, K is going to be multiplied by two different items, quantities. The area of the surface and the square of the speed, which is denoted by the letter V of the wind. So we'll say V squared. Okay, so coming up with this in general is good. And now the problem is going to give you some information to help you find out what the exact number for K is. So wind of 30 miles an hour, okay, that's velocity. Blowing on a window measuring 4 by 5 feet, so area is 4 times 5, which is 20. We don't know what K is yet, but we're going to find it. That gives us a force of 150 pounds. F stands for force. So let's solve this for K. All right, so if you have to, you can go to your calculator and do 20 times 30 squared. And that's 18,000. And then to solve for K, we're going to do 150,000 or 150 divided by 18,000. Now it's okay to get a decimal approximation, but that usually means that you're rounding and it's not quite as precise. So if you can figure out a way to do the fraction form, reduced fraction form, I think that's better. Obviously, if we could get it down to 15 over 1800, and let's see, I think 15 goes into 1800. Yep, 120 times. So in fraction form, this is just 1 over 120. So our equation, our joint variation equation looks like this. Force is equal to 1/120th times area times velocity squared. Now use that to answer the question. What is the force? So we're going to be finding F on a window measuring 3 feet by 4 feet. So area is 12. Caused by a wind of 50 miles per hour, so velocity is 50, and then we'll square that. So we just go to our calculator And it's going to be 12 times 50 squared. And then divide that by 120. And that's 250. So the force is 250. And then just pay attention to how force is represented in the problem, what kind of units. It's a force of 150 pounds, so this would be a force of 250 pounds. Okay, so I think that'll do it. That's all you're going to do for this particular assignment. I hope that helps with the problems that are assigned. If you have any questions, feel free to reach out to me and I'll be glad to help you.